Hi guys, my name is Ernest and this is Ernest Sciences and Mathematics TV channel. Today we're going to look at the concept of vector addition, and this is going to complement on the first video that we had seen on the especially concept of scaling of vectors, whereby we said that that pertains basically to the multiplication of a vector with a scalar quantity. So in this specific case, we're going to see one of the operations that we can be able to do on vectors, and that is the concept of vector addition. Now, this is going to create, of course, a distinction from the various aspects that we have done for the operation of addition and subtraction, and perhaps from the first one of scaling of vectors, whereby we had said that scaling basically refers to multiplication of vectors with scalar quantities. So therefore, we are going to consider in this case two vectors, which are going to lie on the same plane, which of course we can be able to illustrate as vector A and B. And in this particular case, of course, we're going to see that these vectors are going to join one another, this particular tip, and we're going to consider O to be the origin of this specific vector. So we had said that we can be able to do a representation of these vectors using various ways, whereby we have vector OA being represented as vector OA with that specific R on the top. And then, so this is going to be as well be given as vector A with a bar at the top as such. So we have this one being indicated for A, and then we are going to have the line OB being given as OB with an arrow, and then this one can be given as B with a bar at the top. So therefore, the distance between, or the vector OB can be represented as B with a bar given at this specific point. So if we try to find the addition or the resultant vector from these two specific vectors, there's a specific procedure that we're going to use, which is going to, of course, assist us trying to achieve this particular operation. So in this case, I'm going to use our first figure here for illustration. So the first step that we're going to take is to try and move either of the vectors for either A or B parallel to its specific original vector. So in that case, I mean that if we want to move this specific vector for A, then therefore we're going to move it in a parallel direction towards this particular direction. And therefore, we are going to move this one to a point whereby this specific point of where it is joining the origin is going to coincide with the tip of this other vector B. So that's going to move, and I'm going to use a dotted line in order to differentiate this one from the first one. So therefore, if you move vector O to this specific point, then therefore we're going to have these imaginary points for the new vector at B, which I can be able to illustrate at perhaps O prime, and then we're going to have A prime at this specific point. So these are imaginary points that I've said. So the first operation is going to move this specific vector parallel to itself, and then we're going to make sure that this specific point that is coinciding with the origin is situated as point B. So therefore, from that specific operation, then therefore, we're going to create another vector which is going to run from the origin to this point at the tip of A. So let's say this is let me just maintain those ones. So this is O prime, and this is or rather this is O prime that is situated at this point B. So therefore, we're going to consider the resultant vector which has been obtained, which is going to describe a vector from O to A. So this is OA, as I can say, using that one just for the sake of differentiating it from this one, but it's the same point that has been translated or rather moved into this specific point. So we're going to have this resultant vector that is going to be indicated as OA. We can just give it as vector C to differentiate it from this specific two, and therefore it's going to be elaborate for us. So for us to find the addition of our two vectors for A and B, which is vector A plus vector B, which is going to give us vector C, we are going to perform this specific operation that I've said, whereby we move one of the vectors in a parallel direction to the other one, so that we can be able to find a resultant vector. Now, suppose we had this vector given as this, so we can just give this one. So we had moved A in its parallel direction towards that case. So suppose we move B, then therefore parallel to itself, we're going to obtain another vector which is going to be B given as such. So for us to find the magnitude of that specific vector, so this, since they are parallel vectors are going to have this, so long as they are equal, they are going to have the same quantity, and the direction, of course, is going to be the same. So in this case, we're going to have this A at this specific point, and our resultant vector is going to run from this specific direction. So that's going to be C. So we're going to obtain the same result if we try to do an addition of A plus B, which is going to give us a resultant vector, which is C. So this is how we're going to treat vectors whenever we're going to consider addition of perhaps two vectors. And this is the same approach that we're going to use in case we have a number of vectors which are more than two, as I had said. So hence the addition of vectors is going to be obeying what we refer to as a commutative law, which we're going to see later. So as I said that we can be able to change this one and obtain still the magnitude of a C. Therefore, which implies that if we have vector A plus B, this one can be illustrated as vector B plus A respectively. So therefore, this is going to obey what we call the commutative law. Commutative law as far as the operation of vectors is concerned. So this one, among other laws, we're going to look in other videos which are going to assist us, of course, appreciate this concept of addition of vectors by moving the specific vectors in the parallel direction with respect to the original one. So catch us in our next videos. We're going to look at a different strategy of trying to add these particular vectors, and this is going to complement on this specific video that we have had a discussion, particularly on addition of vectors. So check in our description boxes, and kindly request our members to subscribe so that we can be engaging one another in this specific discussion for sciences and mathematics. So that is it for now, guys. By God bless.